Hello everyone. So in this video I will actually try to explain the problem number 50, which is actually a random quadratic equation. So let's move into the brief explanation. So the problem is actually we are given with a quadratic equation, that is x square plus 2bx plus c is equal to 0, and the question is actually what is the probability that this quadratic equation has real roots. So we have to find the probability that what is the probability for that this quadratic equation has real roots. So let's first assume that we have a square. So this is the square, and each side of this square is equal to twice b. So b is this length, so each side of this square should be actually twice b, and we can actually based on the equation we can actually find that small b and c randomly from uniform distribution, and we can actually find this small b and c points from this square box. So now the thing is, as the equation is actually x square plus 2x plus c, so the condition for real roots should be actually b square minus c is c should be greater than or equal to 0. So if b square minus c is less than 0, then we will actually have complex roots. So the next step is actually to draw a parabola based on that condition. So let's actually draw a parabola. So we have actually drawn a parabola here for b square is equal to c. So as the condition is actually b square should be equal to or greater than b square minus c should be equal to or greater than 0. So the next step is actually to draw the parabola for b square is equal to c. So this is the parabola for b square is equal to c, where this line over this line for each and every points it actually satisfies this condition. So for each point on this on this line is a line b square should be c, but inside that region which is actually bounded by this square line, so this unshaded white region, this here is actually, this is the interesting region where b square minus c is less than 0, and all the other shaded region is a place where b square minus c is greater than 0. So so this is the brief analysis of the region of parabola in square. So now once we have actually drawn the parabola, now the question is actually what is the probability of getting real roots. So now we actually can see that this unshaded region, this shaded region, this blue region actually gives real roots, and the unshaded region, this region actually gives us the complex roots where b square minus c is less than 0. So once we actually know the region, then we can actually compare the area, or we can actually find the ratio between ratio between this complex this unshaded region and total area, and that will actually give us the probability of having complex roots. And if we actually find that the ratio between complex ratio of unshaded region with total area, then we'll actually find the probability of getting real roots. So now the challenge is actually now how we can actually find the area of a shaded region by a bounded in between a parabola and an axis. So just for example, like this, for this parabola this equation is actually x square minus 4. However, if we actually look into this graph, it will actually help us to find the area of the parabola, and that is here the parabola actually touches the x-axis at -2 and 2 points, -2 0 and 2 0 points. So the red region is the area we can actually we need to find. So The policy is actually really simple. We actually area of the shaded region, actually we can actually find the area of this region by an integral with a upper limit 2 and lower limit -2. And if we actually find this integral, then we actually we will find the area of this red region. Similarly, we can actually see that this parabola is actually bounded by this upper edge of this square. So if we can actually very easily find the with the same process, following the same process, we can actually find the area of the unshaded region. And here the area of the unshaded region should be 4 by 3 into b to the power 3 by 2. So this is the area of the unshaded region. And obviously, as each side of the square is actually 2b, so the area of square should be actually 4b square. So now we actually know the unshaded region and the shaded region, the total area, the area of the unshaded region and the area of the square. So we can actually definitely find the probability of getting complex roots. And the thing is, if we actually divide 4 by 3 into b to the power 3 by 2 divided by this total area 4b square, then we'll actually get that the probability of getting complex region should be actually this ratio, this amount divided by this amount should be 1 by 3 3 into root b. So if the value of b actually increases, then this value will actually decrease. So the probability of getting complex root will actually decrease. So if we actually deduct this value from 1, then we'll actually get the probability of so if we actually deduct this value from 1, then we'll actually get the probability of getting real roots. So that's how we can actually calculate the probability of getting real roots for a quadratic equation. So this is the explanation. Thanks for listening.